Thank you very much for the kind introduction. And as you indicated, I was a close friend of Mike Sprinkel, and I'm very happy for this opportunity to be here to honor him. We have known each other more than half a century. It's really amazing, isn't it? So let's start talking about Michael. Michael Sprinkel received his bachelor's and master's degrees at the University of Virginia in Charlottesville, Virginia. And he worked at the VTRC, which is the Research Council, Research Division of the Virginia Department of Transportation. We call ourselves Virginia Transportation Research Council, VTRC. And that's where I work as well. And he was very active at ACI and TRB, many awards, and we'll talk about them briefly. Now, how did I get to know Michael? We both were graduate students at UV at the same time. So we were at the same time working together and sweating, trying to get our degree. And then we both worked at VTRC, at the Research Council. These are now early 70s. And we both were amazingly interested in concrete. We both loved concrete, to work with concrete. And another interesting thing for you is that my first ACI paper was a joint one with Michael Sprinkel. And I'll tell you a little bit about that. That was about the hollow microspheres. And it came about again a few years back. People were talking about this topic, and we did it in 70s, type of thing. Now, we were, as I told you, very close to each other. We even lived very close, within 1 mile of each other in Charlottesville. So we went to many meetings together in Virginia, in the United States, and also in Europe. And this picture together, 2007, we are in Switzerland, Zurich. So we were very close. We traveled together, we worked together, and outside work, we were very good friends. So it was a great opportunity, and it was so good to have known him. Now, he was an accomplished civil engineer and research scientist. And he earned many prestigious awards, like this 1988 TRB's KB Woods Award, and then 2012 ACI Robert E. Fillier Award. And then in 2016, VDOT Commissioner's Lifetime Achievement Award. So we had some awards, similar awards. We worked together and we helped each other over the years. And then in 2021, he got ACI Charles Whitney Medal. So Michael did a lot of good things. Now, he was also an administrator. He was an associate director, guided many successful research projects at the Research Council. But believe me, his heart was in research. He loved to do research, and we'll try to get some of those things across to you. And he was a pioneer and industry leader in the maintenance, repair, and rehabilitation of highway bridges and pavements. Oh, he loved that topic. He enjoyed hands-on field applications of new technologies. Again, I'll give you some examples. And he had over 100 VTRC and journal papers, and he prepared many guidelines and specifications for the Virginia Department of Transportation. So he was really a great person, very helpful to the DOT. Now, it always, when you think about Michael, this repair and rehabilitation, protection, repair, and rehabilitation is the first thing that comes to your mind. And here, in 1990, he wrote this manual for the repair and protection of hydraulic cement concrete bridge decks, 1990. And then he updated in 1994, repair and protection of hydraulic cement concrete bridge decks. Look how many years back. And then he did work for the SHARP, Strategic Highway Research Program, and he had this document for them. Rapid concrete bridge deck protection, repair, and rehabilitation, a topic dear to his heart. Now, this is Michael on the left-hand side, as you see, in a meeting. Please look at it very carefully, how serious looking he is at the meetings, okay? Now, let's look at Michael in the field operations. Is he smiling? Yeah, he's so happy. when we went to the field project, he was so happy to be in the field. But when he was in the meetings, he was a little bit more serious looking type of thing. So that tells you a lot about what his interests were, type of thing. So here, he is in the field working. This is a few years back. This is a substructure repair job we had near Charlottesville, Virginia, and definitely he was there watching what they were doing and trying to collect some data. Michael is there. And corrosion. Oh, corrosion is another topic dear to him. And here he's in the tunnel in the eastern part of the state, and he's looking at those panels that had some corrosion problem because of the leaks in the tunnel. So Michael is there. Here, Michael, again working. This time he's working on a paving project. About 10, 12 years ago, we placed bonded and unbonded concrete pavements on Route 58, and Michael definitely was there, and he was very active in that project, and he himself checked the bond strength in the bonded section. He was there on his knees checking the bond strength. That is typical of Michael for you. Here is another interesting thing for you. He's doing some surveys. He actually did the work, as you see. He did the work, and I was told, I wasn't there in this project, but I was told that Michael found some spots that the inspector missed. And he made sure that he knew that. The inspector knew that, you know? Yeah, he knew that. He was very serious about this, you know? He was very serious. That was Michael for you. Now, this is dark because this is inside the segments of a signature bridge in Virginia, and Dr. Sandor Balakumaran will talk more about that. So I just want to show you that how Michael is right there, trying to check out these grouts and then the tendons in that project. But we'll hear more about a very interesting project. So let's look at a few of his contributions. I don't want you to imply that this is all of it. In fact, I missed something here that I want to tell you a little bit more. I will add another item to this one. But these are the things that came to my mind when I was thinking that makes him really very well known all around the world type of thing. So what were they? He worked with air entrainment. He was very much up on it. He worked with high-range water-reducing admixtures. And I'll give you an example. Polymers for cracks, sealing, and filling, and overlays, polymer overlays. High early strength concrete using rapid setting cements. And I think we'll hear more about it in the second half of this, in the afternoon. And corrosion resistant reinforcement. We'll see how active Michael was in Virginia on that. And strands in ducts and grouts. And again, Dr. Balakumaran will talk about it. I won't tell you much. But one other thing came about when I was here, which I should have added, is that Michael, I, and another colleague, Harry, we worked together to improve the specifications or cracking issues, resisting cracking in bridge decks. And we came up with a specification which is very unique. Why is it unique? Because we have a maximum total cementitious material content in the cement. Try to keep the paste low type of thing. So that's very unique. There's no minimum in that. There's a maximum cementitious material. And we have been using this spec in hundreds of bridges right now since 2016. And our people in the field are telling us is that we are getting much better performance out of these concretes, much less cracking type of thing. So this is another very important thing I like to add to this list. So let's look at the air entrainment. As I told you, can you recognize this is me on the left, and that's Michael on the right. And look at the year, 1982, published. We worked on it in 1970s type of thing, you know? Michael had this mustache type of thing, you know, very typical of him, those of you who know him. So this was hollow plastic microspheres, and we found that, yes, you can use these microspheres, and yes, if you use enough of them, you can get good satisfactory resistance to cycles of freezing and thawing. So we published this in 1982, and a few years back, I hear in some ACI publications, this thing came about again. They were talking about these microspheres. And I'll be very happy to tell you more about these things. Since we have limited time, I'll have to go fast. Let's look at the work he did with the high-range water-reducing admixtures. I mean, it's amazing. Look at the date that he published something on this, 1981 type of. It's very interesting. So what he noticed in 1981, at that time, the high-range water-reducing admixtures were different than what we are using now. Now we are using these polycarboxylates. At that time, they had sulfonated naphthalene, sulfonated melamine, formaldehydes type of thing. They were much different family of admixtures. And Michael started using them. He noticed when he worked with these, very new, there was some segregation, there was some slump loss, and control of air was very difficult. These are, again, early, very early applications. But he didn't come about and say that, look, so much trouble I'm having with this product, let's not use it in VDOT. He didn't say that. That wasn't Michael. Michael made sure that he worked hard and he made things work. His goal was not to cut off something. His goal was always to make things work. And you know how successful we use these high-range water-reducing admixtures. And at that time, he also emphasized, because of all these problems we were having, he said, you better have a trial batching before you go to the field with these products. So that was very interesting of Michael. Again, polymers. He spent so much time with polymers. Again, these are very early applications. High molecular weight methacrylates, epoxies, urethanes. And I remember Michael talking, since we were so close to each other, we worked together all the time. He was telling me, Celik, one drum was different than another drum in those early days. So there was so much variability in these products. But again, he didn't say that we don't want to use them. He tried to write specifications and tried to get some uniform products that VDOT can use. And I'm so happy that VDOT has been using these things successfully. Here, polymer overlays. He has many publications. Epoxy concrete overlays. Latex modified concrete overlays. The first latex modified concrete in Virginia was 1969. And then Michael worked and upgraded and made them so useful for VDOT type of thing. I was in a session on Sunday, and one of the speakers talked about latex modified concretes, and he indicated that lifespan is 12 to 15 years. 12 to 15 years. But I know that Dr. Balakumaran here, and you can talk to him, has has a paper, I think it was 2019, that he showed that we are doing much better than that. Our average life is more like close to 26 years type of thing. And I made this clear to the presenter. I said, 12, 15 years. Our rigid overlays, LMC included, much more than that. I made it clear in that meeting. So I want you to remember. So Mike was very active and tried to get these overlays in very good shape. And I believe that Sounder will even do better in the future overlays because we have better surface preparation with hydro-demolition type of thing. And then rapid setting cements. He used them in patches, overlays, and then the first latex modified overlay using a rapid setting cement, which we call very early strength, was built in 1997, and you will hear more about it later, so I won't go in detail. Now, what are these? So he was interested in high early strength because of traffic interruptions is very important. So he worked with rapid setting cements that gave us 2,500 psi in 3 hours. They are then in mobile mixes, as you see on the right-hand side. And here you also see that we have it in a patch in Virginia. Okay, corrosion-resistant reinforcement. This is another topic that he worked so hard, and he recognized the limitations of epoxy-coated reinforcing steels in bridge structures. And he acted as a champion within VDOT to replace ECR with corrosion-resistant reinforcing steel. Believe me, it was not an easy task. There were a lot of people objecting, FHW on one side and some other people, some other DOTs and things like that, but Michael didn't give up. And his efforts have resulted in the successful use of CRR since 2008 in Virginia. We are doing very good with these things. Now, he saw this thing. He's the one who found out that there was an ECR failure, a leaking construction joint. It failed in 17 years in an interstate, I-81, in the western part of the state. And he found that there was, the bar had lost all its cross-section. There was nothing left. He said two different pieces. All lost the thing. So Michael noticed all these things. And then post-tensioning. I'm not going to go too much in detail with post-tensioning, but I like to mention that he worked with prepackaged high-performance grouts. He was very much interested in them. But he observed that there can be bleeding, segregation, and then you could have soft grouts and leaving voids, and then corrosion of strands. And Dr. Balakumaran will tell more about these things. So I am not going to mention more, but what I like to tell you is that while he said that while the VDOT experience has identified many issues with grouts and grouting, post-tensioning structures continue to provide service. Again, Michael there. He doesn't say that, look, we are having so much trouble, let's forget about this. Let's do something else. No, that's not Michael. Michael tried to make it work, and he believes that done properly, we have the grouts that we can use in post-tension ducts. So, in closing remarks, Michael was an accomplished engineer, research scientist, and administrator. He made significant contributions to bridge and materials advancements around the world. He will be greatly missed. Thank you.